Welcome to Manufacturing Tech Australia with Shane Williams and Paul Mason.
Lorna, welcome to Manufacturing Tech Australia. Thanks for coming on the show.
Oh, thank you.
Excellent. So what do we got here? We've got PowerJump is the name of the company. Zukin E3 is this awesome software package that we're talking about here.
Absolutely.
All about optimizing the way that designers and engineers, develop products and maintain their products.
Absolutely.
Give us a bit of a rundown of what you guys are doing.
Okay, well, historically, mechanical power has probably been a big advantage in developing products, but electrical got a little bit overlooked. So that's where we're involved in creating a digital twin of a complex electrical harness that will power vehicles such as tanks, submarines. We're in the original submarine program, which went away. Buses, armored personnel carriers, people carriers, that kind of thing. So what we do is we create the digital twin of the harness, and that can then be imported into mechanical systems, fitment, elimination of human error, and then communicated to a cutting machine to cut the wires, split back the coatings, split the laser IDs on the side, and that kind of thing. So it's a complete end-to-end section, but then it has other capabilities. So for instance, if you're creating a machine which needs a panel that has to be controlled, then we have a panel that will have an intelligent governor that knows all the wires that are coming through from the harness and where they should live inside that panel. Intelligent DIN rails. You've got this assisted method, so you can put this onto a tablet and your technical people can come along and know which components to put on the DIN rail. And they show you the channel being filled with the wires and how you can arrange those wires so that you're not getting fat bend radii, theorists that's going to deteriorate your cables and that kind of thing. But again, eliminates the human error, so you can't get any of those controllers coming into and switch gear.
Yeah, right. Yeah. So it sounds like it's dealing with pretty complex gear, so it's not just for, making a small interface wiring harness, it's more about complex systems like buses and subs and things like that.
We do too. We've got one-man operations in the Pilbara, converting diesel generators into solar generators.
Okay.
And we'll do a small version of this technology for users like that. The unlimited version is for airplanes and tanks and trains. But we can do the smaller stuff as well. We've got a couple of clients that are doing quite, small-scale electrical stuff.
Yeah.
But the thing is that rather than looking to exploit every capability of the software, you look at the part of the software that solves your problems, how much money that saves you. So you only use 20% of the software, and it's solving a problem for you. And it's meaning that you're getting no recall on your wiring.
Yeah.
In fact, you've ROI, right?
Absolutely.
So that's what we're interested in. Being engineers ourselves, we concentrate very much on the tracking and support side of things. We have a philosophy of making our customers as independent as possible, as soon as possible.
Yeah, I was in automotive engineering like 15 years ago, and back then we would have AutoCAD, we'd design up a harness, we'd go try, we'd build the proto, go stick it in the car. It doesn't quite fit, or, but the whole digital twin has completely changed the game, like being able to predict exactly, how much, bend radiuses and potential faults and failures.
Yeah, even EMS coming off the cables. If you've got a small in the ship, for instance, and you've got to run a lot of cable, maybe other services like pneumatics, hydraulics, whatever, through that channel, you need to know what's the heat coming off, what's the energy coming off, how long is that cable lifespan when that sheathing is made of PVC. We're going to get right down to that level of detail, And also what happens is once you've created a wire loom for an entire ship, that's broken into stages of each deck frame, right?
Yeah.
So what you will do, you strip off a schematic for each deck level. So as soon as there's a problem on that level, you go to that schematic, bring out your tablet and say, it's this coordinate. Look it up and you have the wiring diagram. And you can diagnose where the problem is straight away.
Wow. Sounds so much easier.
It is.
For diagnostic fault finding, all that kind of stuff as well.
And so through life service for defence vehicles, the TLS documentation is almost just a drop-off from the design information. So if you have created a product and you're tendering for the through life as well, you've got a head start because you've got the TLS documentation in hand.
Yeah, sure. Yeah. And I guess in terms of integration, can this integrate with SolidWorks and Inventor, that kind of thing?
Yeah, we have an XML bridge, so it will take a schematic, bring it into the mechanical model, and you'll see the wires sort of floating around. And then you drag them and say, there's a penetration in that wall there, or there's a fixture like there. And then what you're doing is you're mapping the wiring through the mechanical assembly. When you pull it out, and you've got your developed links. It means that if you've got good document management systems, once the mechanical changes, it will flag the alert for if there are any implications to design as well.
So good for change management.
Absolutely.
What about other areas of the business, like for purchasing, like extracting out bonds and other areas of the business that this can support?
All parts of it, yeah. So it will generate forms in Excel format, CSV file if you like. So you can force it into any of your allied systems and using, so for MRP, or if you've got, what's the SolidWorks Enterprise, any of that, we're all managing it. So it's pretty well integrable with everything. For bigger systems like your Siemens and your Tiers, we have a dedicated XML bridge for that.
Okay.
So there's not any system we can't integrate.
So no excuses not to get fully integrated in the digital twins when designing up buses and that sort of things.
None whatsoever.
Excellent. Well, thanks for giving us a rundown today. Thanks for coming on the show.
Thank you, Paul.
Cheers.
Thanks for tuning in to Manufacturing Tech Australia with Shane and Paul, recorded on the traditional lands of the Bunurong and Wurundjeri people. For more information, jump on the manufacturingtech.au website. Remember to hit the follow button to join us again next time as we continue to explore the intersection of manufacturing and technology.